Hello friends, today we are going to discuss about the resonance effect. Okay. It is an effect which talks about the movement of electron in any chemical structure. Movement of electron means you have studied earlier the inductive effect. There is also a movement of electron. Okay. But now resonance is slightly different from those inductive effects. Here we will move the electrons which is loosely bound in the structure. Okay. Loosely bound means the electrons which are nearly free, you can say almost free, or which is very easier to move around the structure. Okay. So resonance, the another term of resonance is conjugation. Okay. Conjugation or resonance are the same term, and it says that it is a delocalization of the loosely bound electron, which is pi electron. Okay. Earlier we have discussed there are two types of bonds present. One is sigma bond and another is pi bond. Now just remember that sigma bond is very strong bond. Okay. It doesn't easily move. It is a very strong bond. But pi bonds, or you can say the lone pair of electrons, they are very much free. They can easily move around the structures. Okay. So how it happens, we are going to show you that. Let's start. We always know the definition about the diffusion. You know diffusion. What is diffusion? Diffusion means movement of something from a higher density to lower density. Here is the same. Resonance or conjugation, it means movement of electron from higher density to lower density. Now you have to just calculate the where the electron density is higher and where it is lower. You have to just take it out. Now here we are starting with this structure that will be much helpful for you. Okay. Here there is a pi electron, pi bond, one pi bond and one sigma bond. We already said that sigma bond doesn't move. So the only bond which will move is pi bond. Okay. So this pi bond is attached with two carbon atoms. So one pi bond means two electrons. Here two electrons present in this area. Okay. In this area there are one bond, one pi bond means two electrons. Okay. We are calculating the we are just differentiating the electron density of two centers. Okay. And another center is oxygen. Okay. Here two lone pairs present. All of us know that oxygen have two lone pairs present. Okay. Now there are four free electrons in one center, and there are, you can say, one bond means two electron in two centers. So where the electron density is higher, it's very much easy that here the electron density is higher. So we can easily conclude that the electron will flow from this end to that end. Okay. So how it should be represented? Watch carefully. Watch carefully. Okay. Here we have already said that, come to this side, that two electrons forms one bond. Or can say two electrons makes one bond, and one bond can be represented as one negative charge. These three are equivalent. Okay. These three are equivalent. Now two electrons will form a bond. How? By the movement of electrons. This electron comes here and make a bond between carbon and oxygen. Don't confuse with that hydrogen. It is not directly attached with oxygen. Hydrogen is attached with the carbon atom. Okay. Now the bond which is formed is between oxygen and this carbon. Okay. So that will form here. Okay. Now what happens if this bond forms here? There are 4 bonds around the carbon atom before this bond has been formed. Now when this bond has been formed, then the valency around this carbon becomes 5. How? 1, 2, 3, 4, and the new bond which is forming there, we can represent it in this side. Here we are getting another extra bond which makes the valency of carbon 5. That's not a good sign. You can't make bond around the carbon atom greater than 4. You can't exceed. Just a minute. We can't exceed the valency of carbon beyond 4. So what we have to do? We have to shift this electron density, this pi electron density to another side to compensate this effect. Okay. How? This bond will be shifted on this carbon atom. Watch carefully. This is like a flow in the ocean. You have seen the ocean? The flow is coming and it's synchronized from the deeper end to the sea beach end. Okay. So here is the same things happening from the higher electron density to lower electron density. And this side will make another formation of structure which looks like this. CH2, C, H, O, H. Now what is happening there? There is another bond which is forming. We will represent this bond with a different color. We are writing this with blue color. The new bond which is forming between carbon and oxygen, and this bond will be shifted in that end, and there are no such atom present to make such a bond because this is the terminal carbon atom. So what we have to do? We have to keep this electron density on carbon atom. How will we represent? From this cartoon, one bond means one negative charge. One bond means one negative charge. So we will place this bond into this carbon atom with a negative sign. Okay. Now there is another point which I have missed, that oxygen is giving electron density. The atom which is giving the electron density will have positive charge on it. Okay. When you will do such conjugation, then remember that the atom which is giving the electron density will have positive charge, and the atom which is accepting the electron density will have negative charge on it. Please keep remember this. This is the most important thing. Now this carbon is accepting the electron pairs from this end. You can say in ocean this is the deeper end and this is the sea beach end. The flows from deeper end to sea beach end. So this is accepting the electron density. So negative charge is placed in this carbon atom and it is pushing the electron density. So it will have the positive charge on it. And this is the conjugating structure. This is the structure 1 and you can say this is the structure 2. And this is the displacement of electron. Which type of electron? Pi electron. This is the question you must remember. if it is asked that what electron is making this displacement or resonance, we have to say this is the pi electron because this is very loosely bound, so it can easily go around. Okay. Now we can give an example here that in ocean the water flows from one end to another end, not the soil area, because it is very you can say based part, so it cannot move. It is very rigid part, it cannot easily move. Which part will move? That is which is very lighter, you can say, or which is very loose. We know that the atomic, you can say the molecule attraction between the water is much less than present in any type of solid surface. Okay, you can say in solid the attraction between the molecules is very high, and in water you can say the attraction between the molecules is very less, and if you go in the gaseous phase, the attraction between the molecules is slightly more less than that of water and solid. So which will easily flow? Not the solid part. It will very much easier to flow around the structure which is water part, because it is very much loosely bound between them. Now here comes two types of electrons. One is sigma bond and another is pi bond. And sigma bond is like the solid part, the basement, you can say. It cannot move around because it is very much rigid. So now what will move around the structure? Yes, this is the pi bond. So pi bond represent here the liquid part, or you can say the flow in the ocean or flow in the river, not the soil part which is flowing around. Okay, it's the liquid part which is very lighter or very easier to move around. Now the sigma part which represent the solid part. This merely an example, don't confuse with this. Okay, this is merely an example. Okay, now we are getting two structures. This is the one structure, this is the other structure. Now remember that electron will never stop in the structure. It will always go around. It is always move from one end to another end. Now if you see the oscillator, simple harmonic oscillator or pendulum, you see the pendulum goes this end and then it comes back this end. Not the pendulum is sticking at this end or sticking in other end. It will always move. Now this is the same part where electron moves from this to there. Now electron density is getting heavier in this side, and electron density becomes very much less in this side. Now the reverse flowing will take place. How? With the same way, from higher density to lower density. How? Just see, just watch carefully. This negative charge means electron pair. We know negative charge means electron pair. It will go from higher end to lower end. Now it will flow here to make a bond. Now the carbon is getting beyond 4 valency, so it will again lose such an electron pair or give away its electron pair to this end, to the oxygen atom. Now what structure will form? Will be formed here. The double bond will take place. You can see here it is coming back to this structure. The double bond will take place and the negative charge will be disappeared because it has given away its electron. So the double bond has taken place in this side. Now this double bond will disappear and the electron density will go to the oxygen atom. And you know that one electron density means negative charge. So this is, you can represent there is a negative charge and there is a positive charge. Now negative positive becomes neutral. So we won't get any such a charge on oxygen atom. And you can see that In oxygen atom there is no such a charge. So what's happening here? From structure 1 we are going to the structure 2 and the electron flow is reversed back and coming back to the same structure. This is the resonance. This is the conjugation, you can say. And it's coming from higher electron density to lower. Then in this structure the higher electron density becomes in this side. So it's flowing from higher to lower again. And thus the resonance will always going on. It never stops at any end. It's like a pendulum. I think you can understand this effect. Now, coming back to the above problem, the first problem which I am giving to you. Now, where the electron density is higher, just calculate. There is one pi bond between carbon and carbon, and there is another pi bond between this carbon and carbon. Okay. Now, how will it flow? Here, two atoms there, where two electrons present, two pi electrons are present, because there are one pi bond. And in this structure, there are another pi bond which is present. So there is no such center where the electron density is higher, because in everywhere, in both of the part, the electron density is same. How? Two electrons in two centers, here are also two electrons in two centers. So how will it flow? If such a things happen, then what do we have to do? Then we have to calculate the electronegative atom. We have to find out the electronegative atom. Is there any electronegative atom? Yes, there is an oxygen electronegative atom. So you can easily conclude that oxygen is pulling the electron density, because naturally electronegative atom will always pull the electron density from the other end. So you can say that the electron will moving from this end to that end. Okay. Now in this case, what happened there? There are high electron density and there is lower electron density. So it will flow from this end to this end. Okay. That's very simple. But in this case, there are no such center where the electron density is higher or electron density lower. There is no such imbalance in the electron densities in two parts. So then what you have to do? You have to find out the electronegative atom which will pull the electron density from another end. Okay. So how should I represent this? It's very simple. The oxygen atom which will pull away its electron density towards itself. How? This electron density will pull out in this oxygen atom. Now what will happen? If it's coming from this side, then the electron density of carbon will get decreased, because there are 1, 2, 3, 4 bonds. If this bond shifts to this oxygen atom, then the carbon will have only 3 bonds. Then it becomes electron deficient. So it will again pull the electron density from this end. How? This is very easy. We have to make the 4 bonds on carbon atom. If we does this, what will happen there? I am showing this here. If that type of things happen, then the carbon oxygen, what will happen there? Then oxygen will get the negative charge, because one electron density, we are going to say that one pi bond means 2 electrons, and 2 electron means 1 negative charge. Now this electron will shift to the carbon, to the oxygen atom. So oxygen will get the negative charge, and the carbon is losing its electron density. So it becomes the electron deficient. Now it will again pull the electron density from this end. How? From this end to that end, to complete its 4 valency. How? Carbon 1, 2, 3. Here is 1, 2, 3. If it comes from this end to that end, then it will become 4 valency. That's how it is moving from one end to another. Now, which atom is sacrificing its electron density? Yes, this carbon is sacrificing its electron density. We have said earlier that the atom which will lose the electron density will generate the positive charge on itself. So it's very easy to say that this carbon will get the positive charge. The positive charge. And it's shifting from this end to that end, this end to that end. So electron is flowing from left to right in this case. You can say this is the structure 1. You use that this is the structure 1 and this is the structure 2. Now the electron density in the structure 2, electron density is getting heavier in this end because there are negative charge and there are positive charge. So the reverse count will begin. How? This negative, it means 2 electron, it means 1 bond. It can make 1 bond. So negative charge will go into this side to make the previous bond, and this carbon will exceeding the valency beyond 4. So it will lose 1 electron density or 1 bond. It will flow will push back to this carbon atom because this is electron deficient. Now what we will do in this structure, in the other structure you have to do the exact opposite. Okay. If it flow from left to right, then in this structure it will flow from right to left. Because it's like a pendulum, it will never end. It's just going on, going on. So this is the conjugation. In this class we have just discussed these 2 examples. In the next class we will try to give another example. Okay. Now the key point which I have learned is resonance effect means conjugation. So resonance, you can say resonance means conjugation. And what is conjugation? Conjugation means delocalization. Conjugation means delocalization of loosely bound electrons like pi electrons or lone pair. So delocalization of pi electrons and lone pair. This is the important part. We have to remember. Localized thing means it is sitting in this state and it will never move around, which is sigma bond. It is localized one. But pi bonds are very much loose. It will go from one end to another end. Then again the electron density, where the electron density is getting increased, then it will come back to the another end. That's how the electron density is moving around the structure. It's very interesting thing. So just watch the video again and again so that the concept getting into your mind. Now student, try to draw the resonating structure of the given compound and send me in the WhatsApp group. Thank you very much.